Hey class, tonight we're going to go through scales and demonstrating them a little bit. So we'll walk through this first week worksheet exercise together. I know last time the camera kind of projects a mirror image, so it makes it a little bit confusing for me because I see everything in mirror on my screen, but then it straightens it all out when it makes it a presentation. So we're going to assume the same thing's happening tonight. So if I seem a bit confused, that's what's going on. So hopefully you have gotten your scales. This is, again, is the architectural scale that's got the fractions on each blade. And then this is the engineering scale that has the whole numbers on each blade. And that's because this engineering scale is in decimal. So we're going to roll to the 10 blade, and we're going to start to measure the different scaled lines that are on this worksheet. Now know that when you guys print this out at home, and I haven't handed it to you and printed it out collectively, a lot of printers will change the size of the drawing just a little bit. So if you don't end up with exactly the same numbers, it may be because your printer has shrunken or enlarged the actual lines and text on them. So don't get too stressed if it's not exactly close, if it's a little bit off. And some of these will also round up or round down, and that just depends on how good of eyesight you have sometimes. So I tend to use a pair of reading glasses with magnifying to help a little bit with that. So we're going to start with engineering scale, and we're going to start with the 10 scale right here at the top. And you're going to start scaling by laying your 0 right at the edge of the line, and you're going to follow your line along and go to where the line ends. Now on my size printout, this is actually a nice easy one because it falls right on the money of one of my whole numbers. So this particular line is 50 feet long, or it should fall right on the 5 or right about on the 5. Now again, your printer could make it a little larger or longer, but for my printer, it printed out right on 5. So because this is decimal, we have to add the zeros. So with engineering scale, we always say 1 inch is equal to 10 feet, 1 inch is equal to 50 feet, 40 feet, 100 feet, depending on what blade we're using. So in this scale, 1 inch is equal to 10 feet, and I go all the way down. I have 5 inches, so that means that my length of the line is going to be 50 feet. With engineering scale, I don't have the ability to measure to the nearest inch, so we round up or round down to the nearest whole foot to the best that we can. Now we're going to measure at 50 scale. So I'm going to rotate my blade and find the 50 scale. It's right over here. And I'm going to start this the same way. I'm going to line up my edge right at the 0. So my line starts there. And then I'm going to measure where it ends. So on this particular line, I can see it is longer than 18 or 180 because I have to add that 0 at the end with engineering. It is shorter than 190 or 200, which 200 or 20 is the next marked increment. So I can see it's between 180 and 185. And if I read it with my old eyes, I come up to about 183 on my printout for how long that line is at 50 scale. It's 183 feet. Now you might have slightly more, slightly less, but know that you should be in that basic general range. The next line, we're going to measure at 30 scale. Again, I'm going to line up my 0. I've rotated to that 30 blade, lining up my 0 right on the end of the line. And you can see, you know, if 1 inch is equal to 30 feet on this particular scale, for those of you who've grown up with our American system, you can see 20 and 40. So 30 would be right about right there. That's kind of your check. That's about 1 inch and it's 30 feet. Because the biggest thing that messes up students just learning scaling is forgetting to put the 0 on engineering scale. So this is kind of your back check, reading 1 inch is equal to 30 feet. That's about 1 inch, it's 30 feet. So if I have something down here, I know it's not 14, 15, 18, because that would be out of keeping with 1 inch equals 30 feet. I have to add that 0. So now we're going to measure the length of the line. Starting at 0, the line ends before 118 or 180. It would be 180 with the 0. It's after 170. And if I look at this on my printout, I'm going to say, if you see 160s here with the 16 and 170s here, I'm at about 174 is what I get on my sheet. Again, if your printer has shrunken or enlarged this, you might have a slightly different number. Last scale for engineering we're going to practice with is 100 scale. And this is the beauty of engineering scale. It is like a metric system in that it is a decimal system, but we still measure in the standard feet drawing. So I'm going to go back to that 10 scale, but now whichever increment I'm going to select, I'm going to add 2 zeros on the end of it. So I'm starting at 0. My last whole number is 4. I don't make it to 5, so I don't make it to even 4.5, right? So if I'm at 100 scale, this is 400 feet, 410, 20, 30, 40. I'm going to say about 440 feet for that last line is what I measure that at. Oh, and you guys can see that? Good. Okay, so now we're going to move on to architectural scales. Architectural scales are generally smaller. We tend to use this at more of a, a single parcel, house, property, so that we can fit it all on one page, right? So we're drafting proportionally to a scale to fit it on a certain size drawing. And architecturally is about the size of one building on a lot. When we start to get into engineering scales, these are for bigger properties. So if you think about doing a mile planting design for a mile-long stretch of the freeway, we would be in engineering scale. Or if we had a project site that was 20 acres, 50 acres, 200 acres, we would be in this engineering scale. Architectural works for like a 1 acre parcel size or few acre parcel size. So now we're going to practice reading our scaling with architecture. We're going to start with 1 inch is equal to 1 foot 0 inches. So let's take a look at this blade first. Here's our scale with the 1, and this means 1 inch is equal to 1 foot. And you can see real clearly on this blade that we have this like mini measuring tool to get to the nearest inch. It's spread out over that nice long inch so we can really read it clearly. So we would start, like we always start, of lining up the edge of our line on 0. And with architecture scales, you always want to choose the row of numbers that is at the same level as the 0 that you start with. So in this case, we're using this lower row of numbers, right? And you can really see these are each one's about 1 inch apart. So 1 inch is equal to 1 foot. And we're going to go ahead and measure this line. I'm going to start with 0 right at the end. Oh, we end up right on 5. So once again, we get a real even number. I actually would have liked some inches on this because this little measurement tool is so easy to read at this scale. But we've got a line that is 5 feet long, right? Starts at 0, 1, 2, 3, 4, 5. So when I write an architectural scale, it looks a little bit different. I'm going to say 5 feet, and then I always show the inches, even if I don't have any to measure, because it's about the level of accuracy, and we have the tools to measure to the nearest inch. So somebody looking at this would know that this is 5 feet and it's exactly 0 inches. We measured to the nearest inch. Now say my line extended further out. Say it went out to here. Now I'm just going to show you how you use this nice long scale. So you can see here's where my 5 feet ends. And if I was going to have to measure this part that is longer than 5 feet but shorter than 6, I would use this handy dandy little tool at the end. So I could mark it to my last whole number and measure this tail. And you can see when I do that, I end up with about 3 inches. So if my line extended a little bit further, I could expect about 5 feet, 3 inches, if that was the original line length. And that's how you would use that little measuring stick. Now we're going to practice at 1/8 of a scale. So we're going to rotate that blade, and we're going to line our 0 right up at the end. And we're going to use the level of numbers that runs top, close, in alignment with that 0. So you can see I have 28, and then 29, which isn't marked. And you can see it gets confusing when you're laying 2 scales on top of one another. So 28, 29, oh, and that falls right on the money to me at 30 feet. So at 1/8 inch scale, I would say that line length is 30 feet, 0 inches. Now if we go to a 1/4 scale, we're going to go slide down. Here's our 1/8 inch scale. We're going to slide to the other end of my scale. I have the camera in the way, so I'm going to have to flip it upside down. I apologize. So I'm going to still line my 0 at 1/4 scale. I'm going to move this because I don't want to confuse you guys. Okay, so I'm starting at this end, and I'm lining my 0 up at the very edge of the scale. And now you can see my 0 is aligned with the lower set of numbers. So that's what I'm going to use to count. And that's all architecture and engineering scales do for you. They're really just a tool to keep track of counting for you. You could use your standard school ruler for architectural scale and just keep track of every 1/8 inch would be a foot. So this is really a tool just to keep track for you. That's all that it does. You could find decimal rulers that do the same thing, and they would keep track of, you would have to keep track of how many there are. These scales really just, that's their greatest gift to us, is they keep track of how many we're using. So I'm lining up my 0 at the end, and I go all the way down, and I can see my last whole number. Here's 22 is marked, and 23 is not marked. And then I have this little tail that doesn't make it to 24. So now I can use that tail that I marked, and I can use my little mini ruler. And I can line my 0 up on the scale of this little ruler gradient right here. If you can see it right there. That's like a little mini ruler at 1/4 scale. So I can see it's just shy of 6 inches. And this is a pretty small scale. And most of these have the end mark. So 0 foot, 1 foot. In the middle would be 6 inches. And then it's usually broken at a minimum again. So you could say 3 inches, 6 inches, 9 inches, 12 inches. So I can see this is just shy of 6 inches. So I'm going to say 5 inches. So I have to measure this again because I forgot to put the whole foot was. So we're at 23 feet, 5 inches. And that's the way we write it. We have the whole feet, dash, and then the number of inches after it. Last scale, itty bitty scale, is 3/32. I'm going to rotate to that blade. I'm going to line my 0 up right at the end. I'm going to be using that upper row of numbers. You can see 44 is my last whole number. Doesn't quite make it to 45. So I got this itsy bitsy tail at the end. And I'm going to use that with my scale. And it looks like it's just over 6 inches on this one. So again, I am at whole feet of 44 feet. And then I'm going to say, we thought it was just over 6 inches, so 7 inches. It's just over. So 44 feet, 7 inches is what I read. Now with architectural, it's plus minus several inches, accepted accuracy. For engineering scale, we might say plus minus 1 or 2 feet for accuracy. So I'd like you to scale your own. You can verify, hopefully you followed along. If your numbers end up slightly different, that might just be a printing issue. And the last piece you'll do is fill out the remaining countries that still use the kind of standard measurement system. For those of you who grew up with metrics, I included some standard conversions for you, so hopefully you'll find them helpful. And I just apologize for our crazy American standard system if you have primarily used metric system. All right, so that's your introduction to scaling. I hope that was helpful for you.